This puzzle is called Eccentric Sumlines by TopAutism. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look at the rules. So the blue lines have the same sum, so these three cells will add up to the same as these two cells. And then on the yellow line, every adjacent pair of digits sums to a different number. So this is, if you watched the Analytical Ninja puzzle earlier today, it's the same rule set. So, how should I describe? So like these two are going to add up to some value. These two are going to sum up to something different. These two are going to sum up to something different, and so on. It's a pretty cool rule set, so let's hop on in. I'm going to put a link to the puzzle down in the description if you want to give it a try yourself. This probably isn't too crazy difficult. So let's take a look. 1, 2, 3, 4, 5, 6. Let's see, 2, 3, 4, 5, 6, 7. Okay, so it's not all of the different combinations. That's one thing with the earlier puzzle I didn't look at. The earlier, that I should have looked at was how many different combinations there are. Because in a 2x2, or sorry, in a 4x4 puzzle, you can only have a pair add up from 2 up to 8. So there's obviously limited options, and we need a lot of the options here. But I think there's one that won't be used, but all the others will be used. But I don't see how to use that fact immediately. The first thing I see, I think we can do it twice. So pink and green must sum up to different values. Because of course that's what the yellow line means. They must have different, every pair has different sums. Which means that no matter what we put here in this cell, this overlap cell, the two non-overlapping cells must be different. If we put a 3 here and put a 1 here, if we put a 1 here as well, of course this is 4 and this is 4. But it doesn't really matter what this value is. The important thing is that the two outer cells are different. So we can actually just kind of keep those colors and know that these are different values. So we could put pink down here, then and green here, because just with basic Sudoku, because we need a green in column 4 and we need a pink in column 3, and this is the last spot for each that's available. And I think we can do the same thing kind of along here. So we have pink, which will be these. Yeah, we have these two cells, then we have these two cells. Let's color this one blue. So we have the same sort of situation where it doesn't really matter what this is. Let's say it's a 3. If we put a 2 here, we can't also put a 2 here because that would make this pair add up to the same as this pair. So these two must be different, and this can't also be green because it sees a green. So it's a third color, third digit. So where can we put pink in this row? It must be all the way down here. Where can we put blue in row 1? Must be here. And this is just the the fourth color. Okay. I guess this must be a pink as well. Oh, just by basic Sudoku, I mean. Okay. So what can we do here? What color could this be? It can't be pink, and it can't be green. We've already done green. We've already done green pink. So this is blue or yellow. Where are the blue? Why am I having trouble finding blue and yellow? That's the easy step, is just finding the colors. So green in row 4 must go here. We're just going to finish it off here. And then put a yellow here, which means this can't be yellow, it must be blue. Make this not blue, this yellow, this blue. Okay, so we've colored the grid. Now we have to worry about adding things up. So the only thing that I can see is the relationship of the blue lines. The blue lines have to sum up to the same value, and they both have at least one pink on them. So these kind of cancel out. So we know that pink plus green equals yellow. But that is, so pink plus green equals yellow. So this is 3 or 4. This is 1, 2, 3, with one of them being 1. So we need We don't have double yellow along the line. What doubles do we have? We have blue, double blue, and we have double green. We know green is not 4 because it's part of green plus pink equals yellow. So we know this is not 4. But we know one of them is 1. So I think this goes back to what I was saying at the beginning, how there's we need to use 6 of the 7 different combinations of pairs. So this could be there's 1, 2, 3, 4, 5. Yeah, there's 6 different pairs. And there are 7 total different combinations from 2 up to 8. But green. What was I saying? Now I've lost track of what I was saying. No, but pink. Or sorry, but blue could be 4s. Darn it! Sorry. I had a thought there that somehow this forced something. Maybe I did have a thought there, and I just can't remember it. Because we need double 1s or double 4s. If not both, although both is... Yeah, both would be fine, but we need at least one of double 1 or double 4 along this line. And and we know double blue is not... We know blue is not 1. Because 1 is pink or green. We know this is pink or green. So this can't be double 1. This can't be double 4, but this could be double 4, or this could be double 1. Oh, darn it. I thought I had something there. I don't think I did. Okay, well, here's something. What can blue be? Blue can't be 3. If blue was 3, that would make yellow 4, which means these two add up to 4, which means they need a 3. So that breaks, because we would have 2 different digits be 3. So it's 1, 2, or 4, but it can't be 1, so blue is 2 or 4. Maybe there's a better way of doing this, and I'm just being silly and making it harder on myself, which is kind of what I do a lot. So that could account for the double 4s. And one of these is a 4. If this is a 2, then this is 1, 3, this is 4. I think there's something I'm just not quite getting. Could this be 3? If this is 3, this is 1, this is 4, which means this is 2, and then we don't have... We're not using either double 1 or double 4. So green can't be 3 either. So this is 1 or 2. So there's something... Is one of these necessarily 2? No, we could... If this is 4, this is 3, this is 2. This is 4, this is 3, which makes this a 1, 2... Sorry, makes this a 1, 2. Because it has to add to 3. And also by Sudoku. So if this is 4, this is a 1, 2... No, but that means this could still be 1. That would be fine. What am I talking about? There's a piece of logic that I'm not understanding here. This can't be... No, this isn't... This can never add to 5. What am I talking about? One of these is 4. What am I missing here? One of these is a 4. So this adds to 6 or 7. Okay, so where can we have... No, we don't necessarily need 7 because we could do 1 and 4. this could also be, no, this couldn't be if this couldn't add to 7. If this is a 3, this is a 2, because this is a 1, and this is a 4. Yeah. If this is 2, this is 4. If this is 2, this is 1. But I don't see a way to prove that 1 and 4 can't both happen. Just really easily. Well, this is trickier than I thought. This setter is a tricky setter. I have come to find out that over the months they make pretty tricky puzzles, but this is even trickier than I thought it would be. So if this wasn't 7, it adds to 6. Which means it must be 4, 2. Which makes this 1, 3. So another thing we do have to, I don't see, maybe I just didn't carry that long enough and could have seen something, but one thing we do have to realize is that there's 2 different ways of making 5, and we have to avoid having it happen twice. So if this is a 4, this is a 3. No, wait, what? If this is a 4, this is a 3, this is a 1 or a 2. What am I talking about? Why did I say this was a 3? No, I was thinking if yellow is 4. If yellow is 4, this is 3. Which does break the puzzle. Okay, so if yellow's 4, then the only way that we can do a 3 along this pair is by putting it here. And we end up with this situation. But then we have 5 right here, and we end up with 5 right here as well. So yellow can't be 4. Which means this is a 1, 2. And this blue is 4. Okay, now we need to avoid making both of these add to 5 once again. So this must be 1, this must be 2. And there we go. Let's just double check this line here. Let's remove the color for a second. So we have 4, we have, oh, and it does end up with both of the doubles. But anyway, we have 4, 2, 3, 6, 8, 7. And we actually just avoided 5. That's, did we avoid, did I miss 5? No, we just avoided 5, which is like the tricky one because you can get it in 2 different ways. Yeah, that was very good. That was a very tricky puzzle though. But thank you for that, TopAutism, for that puzzle. That was a good puzzle. I like this constraint. It is a weird one, but it's a good one. And thank you all for watching.